Find a possible solution for f of x, given that f of x equals integral of e to the negative x, natural log of e to the x plus 1. Okay? Okay. So first try substitution. And I try really hard with substitution here because this just looks confusing. So we take the integral of e to the x plus 1 and we get e to the x. If we take integral of e to the negative x, we get e to the negative x times negative 1, which really doesn't help us. So we're going to try integration by parts. So start with the formula for integration by parts, which is always uv, there we go, plus u prime v. This is the product rule. Rearrange the product rule and we get something like uv prime equals uv, quantity primed, minus u prime v, integrate both sides, and we get integral of u dv equals uv minus v du. You would think that like I would have that memorized by now. Turns out I don't. Memory of a goldfish. And there's some things I just can't remember in life. Maybe I learned the wrong mnemonic or just something, but it got stuck in my brain kind of like at a slight angle when it should have been, square, and just kind of not quite right. So, long story short, that memory is ruined. That penguin has deserted the iceberg. Okay, so that's one of the reasons why I derive it every time. So we then use I late as our mnemonic. Oh, there's an E at the end. Inverse trigonometric, logarithmic, algebraic, trigonometric, and exponential. And we have a logarithmic and we have exponential. So we're going to say that u, even though there's also an exponential within the logarithmic, which makes me worried. Tense. Okay, so then we have natural log of e to the x plus 1, natural log of e to the x plus 1. And then we have dv, which will be e to the negative x. So then v will be e to the negative x divided by negative 1, which will be the same thing as multiplying by negative 1, so it will be negative e to the negative x. And then du will be the derivative of e to the x, so we have 1 over e to the x plus 1 times the derivative of the interior, which is e to the x. Interesting. Interesting. So that's the chain rule. So we have e to the x over e to the x plus 1. And this will then bring us to using our formula. Click, clack. Or maybe just click. I'm not sure. Ooh, gray. I enjoy using gray. I don't know why. It is a personal joy, pleasure that I find in life. So clear, so crisp, but not quite as harsh as black. Not that there's anything wrong with black, just a little overpowering sometimes. Okay. Minus integral v du, negative e to the negative x all over times e to the x plus 1. Okay, so then we multiply e to the x, multiply by e to the minus x, we add the exponents. So if you thought of like 2 to the, first times 2 to the negative first, that would be the same as 2 times 1/2, and that would be the same as 2 to the 0, which is 2 to the 1 plus negative 1. So we're going to do the same thing here, x minus x, or x plus negative x. And so we get negative 1 over e to the x plus 1 minus integral, and then the same thing will happen over here. Exponents will cancel each other out, and we'll get the plus side over here, so we'll do plus 1 over e to the x plus 1, and I should have kept along the dx just in case. Now, I don't know how to solve this. I don't know if that's a trig table or if it's like a, because those are those squares? No, they're not squares. There's something that goes on there. Maybe some sort of arctangent. Let's see what options we have here. So we have, so they let us keep the integral, which is kind of nice. So I'm going to assume it's one of these because it maybe, we'll see. Okay, so we got, interesting. Did I miss something? Maybe I missed something. So we had, maybe, okay, so down here I used, here I used du when I should have just used u. So this is actually, go back to gray so I can kind of show where I'm backtracking to. This should actually be, let's see, u times v. So it'd be natural log of e to the x plus 1 times negative e to the negative x. Okay, so we have negative e to the negative x. So it'd be here and here, check. Natural log of e to the x plus 1. Check. So the only difference between these two is the sign. And we had a positive sign, so it'll be this one right here. And the reason that sign was positive was back here when we took the integral of e to the negative x, the integral of e to the negative x is negative e to the negative x. And so that's why we got that sign changed over. So, and then it's 1 over e to the x plus 1. Check. Okay, so everything else is good. See, that's why I kind of like multiple choice questions, because if you are way off, then sometimes you're like, your spider senses will trigger, which is nice. Okay, so look at what we did. Nice. Okay, so looking at how this went down, we had a problem. We weren't sure how to do it. We tried substitution real hard because the exponents scared me. It didn't work out. And so then we look at integration by parts. And we look at I late as our mnemonic. We had a logarithm and an exponential. So we took the logarithm as u, we plug things in, and we get this integral that I don't know how to solve. Maybe I do. Maybe if I putzed around enough, I could figure it out. But it's not easy. And maybe it is. No, I don't think so. And I couldn't solve it. So then at that point, I kind of gave up and started looking at the answers. And it's like, oh, these are kind of close. One of the mistakes I made was instead of using u times v, I used du times v. Totally wrong. Totally wrong. And so eventually I looked back and fixed it. So that is how we solve this problem. Try not to make the same mistakes I do. Ideally, I'll make the mistakes so you don't have to. It's much easier in life to learn from other people's mistakes than your own. So that is my little wisdom for the day, your little piece of zen that I'll throw out there. Thank you much. I will see you on the next problem. Take care.